All right, welcome back. We're going to continue with logarithms and their functions. This is day 2. We're going to do the examples I didn't do yesterday. So we're going to start with example 3. If we look at example 3, we have some logarithm equations, and it says solve for x. So on the first one, we got log base x of 1/4 is equal to 1/2. So we're going to do it similar how we solved just a logarithm expression yesterday. So what we're going to do is we're going to rewrite this logarithm equation as an exponential equation. So again, it's all about the base. So let's start with our base, which is x. Let's do the circle of life. So we're going to go x to the 1/2 power is equal to 1/4. Okay. Now yesterday, our variable was located in the exponent. So we rewrote both sides as powers. Well, today we have x. My x is in my base. It's x to the 1/2 is equal to 1/4. Well, this is actually a radical equation. We just did this in the last chapter before spring break. Because remember, if you have a to the 1 over n power, that's equal to the nth root of a to the first power. So what we really have here, x to the 1/2, you can think of that as the square root of x. How do you solve a radical equation? You get your radical by itself, and then you raise it to a power of that index, right? So we're going to raise it to the second power. So what I want to do to solve this is I want to square both sides of my equation, because it's a radical. So like I said yesterday, everything that we have covered this year is going to come back in this chapter. You're going to probably see it. So it's really important that you've been keeping up with your homework and doing it on your own and not using Photomath. All right, so we got x to the 1/2 squared. Well, 2 times 1/2 is just 1, so this is x to the first power, just x. And then that's going to equal 1/4 squared is 1/16. So x is equal to 1/16. All right, let's look at b. Log base 3 of x is equal to 2. So again, we're going to start it off the same way. We're going to start with our base. It's all about the base. 3 to the second power is equal to x. Well, how do you solve this equation? Well, x is already by itself. It's already solved, but it's just not simplified. What is 3 squared? 9. So x is equal to 9. Okay. Also, I forgot, we should be checking to make sure we can use these as solutions. Because remember the definition I gave you yesterday. When you have log base b of n, remember your base can't be a negative number. Your n can't be a negative number. So we gotta be aware of that. Also, remember the base also cannot equal 1. So make sure your base is not 1 also. So what was x on this one? X was 1/16. What was 1/16? My base is 1/16, a positive number. So yeah, we can use x equals 1/16. Over here, x was what I was taking the log of, which is my n value. Remember, the n value needs to be a positive number. So if we were to get a negative number for x, we know this would have been no solution. So be aware of that. Your base has to be a positive number, and it can't be 1. N has to be a positive number. It can be 1. N can be. Right, C, we got log base 1/3 of 27 is equal to x. So this is just like what we did yesterday. So we're going to go 1/3 to the x power is equal to 27. Well, where's my variable? It's in my exponent. So when your variable is in your exponent, you want to rewrite both sides as powers of the same base. Well, everyone should know 27 is 3 to the third power. Over here, we could make 1/3 raised to the x power. We can make that 3 to the negative x power. We can use that negative exponent rule to flip our base. So now they have the same base. They both have base 3. So that means we can set the exponents equal to each other. So we get negative x is equal to 3. So x is equal to negative 3. And this is what your log is equal. That can be a negative number. These two numbers right here, that number and this number are the numbers that can't be negative. So we're allowed, that number is allowed to be negative. All right, before we do D, I just want to show you a little trick here. So yesterday we was doing problems like this, expressions like this. If I had log base 2 of 8, and I wanted you to solve it, I want to know what is log base 2 of 8. Well, how we did it yesterday is we just set it equal to x, and then we rewrote it as 2 to the x power is equal to 8. And then I had you rewrite 8 as 2 to the third power, and we got x equals 3. Okay? Yesterday on the homework, I said I wanted to see that work. Well, today, I want you to get in the habit, I want you to try to do it in your head. Okay? But if you can't do it in your head, you can always show the work. But I do want you to start trying to do some of these in your head. It's important that you can. Just for ones like this, when you're taking the log of some base of some number. Not the new ones I'm showing you today. Just ones that are set up like this. A logarithm expression where you're trying to find the log of that. So basically, here's the trick. Basically, here's what you ask yourself. This is, you can just think of this as you don't know what it is. You're doing the same thing, but you just do it in your head. You're going to ask yourself, 2 to what power is this number? If you want to write that out, you can write that out as part of showing your work. Or you just say it out loud. 2 to what power is 8? 2 to what power is 8? 3. So log base 2 of 8 is equal to 3. Okay? All right, so keep that in mind for this example that I'm getting ready to go through here. We got this equation here. The log of base 2 of the quantity of log of base 2 of the quantity of log of base 2 of 16 is equal to x. So it's already solved. X is by itself. It's solved for x. We just got to simplify that left-hand side. Just like we did on the example right above it. When we rewrote this as 3 to the second power equals x, x is already solved for. We just had to simplify this. 3 squared is 9. So what we got to do is we got to simplify this. Okay? Just because we have logs involved, it doesn't change how we do it. We're still going to do it by order operations. So whenever you got grouping symbols within grouping symbols, you always start with your innermost grouping symbols. So we're going to start with this right here. I want to know, what is log base 2 of 16? Well, this is one of those ones I want you to now try to do in your head. So let's think about this one. What's the base of that logarithm? We got log base 2 of 16. So what are we going to ask ourselves? The base of our logarithm is 2. So we're going to ask ourselves, 2 to what power is 16? 2 to what power is 16? 4. So log base 2 of 16 is 4. So we can replace log base 2 of 16 with 4. Okay? Does everyone see what I did there? All right, so now we're going to do the next innermost. So now we need to figure out what is the log base 2 of 4. Well, what's going to be the question that we're going to ask ourselves? This is your base, right? So you're going to go 2 to what power is this number? 2 to what power is 4? 2. So log base 2 of 4 is 2. So now we just got this. Log base 2 of 2 is equal to x. And then again, we can do that same trick. What is log base 2 of 2? And then that's what x is going to be. So again, here's our base. We're going to go 2 to what power is this number? 2 to what power is 2? 2 to the first power. So log base 2 of 2 is just 1. So x is equal to 1 on that one. Now, let's look at e. E looks really complicated, but it's really not. But when you see a problem like this, when you have a logarithm written as an exponent, and the base of your logarithm matches the base of your power, they basically cancel each other out. I'll show you why. But really, when you have like 2 raised to the log base 2 of 5, the 2 and log base 2 will cancel out, and you just get that number 5. So the answer to this equation is just x equals 5. Okay? I can show you why this works. It's related to what we worked on yesterday. But for ones like this, when you have a problem like this, I'm not going to require you to work. You can just mark these out and just put 5 equals x. But I'll prove it to you why it's true. So, yesterday, I gave you 2 equivalent equations. N is equal to b to the p power. I said that was equivalent to this statement. P is equal to log base b of n. So, if we look at this equation up here, this is written as a logarithm. I mean, it's not written. It's written as an exponential equation that has a log in it. So I got a power here. I can think of 2 as my b. My exponent, my p, is log base 2 of 5. That's my p. And my n is x. So let's rewrite it as a logarithm equation. So what was my p value? My p value is my exponent. So I'm going to write log base 2 of 5. What does that equal? That equals log of your base. What was the base over here? The base was the number 2. And then what's your n value? Your n value is x here. So we got this equation here. Log base 2 of 5 is equal to log base 2 of x. Well, the only way 2 logarithms can equal each other if they have the same base, which these do, is if these numbers are equal to each other. So that's why they cancel each other out. That's why we get x equals 5. Okay? That's actually the next property that we're going to look at. So this property here is very important. So it says if you have a logarithm equation, so if you have log base b of a is equal to log base b of c, so if you have 2 logarithms and they're equal to each other and they have the same base, then what's true is you can think of it as the logs parts canceling each other out, and you just get a equals c. This is the new stuff for today, but this is what we're going to be using to solve some more logarithm equations. Really simple. Now, if the 2 logs are equal to each other, and they both have the same base, then whatever you're taking the log of on both sides, you can set them equal to each other. It's kind of like the exponent rule. It's kind of like what we were doing yesterday. If you have like 2 to the x power, that's equal to 2 to the third power. If you have two powers and they have the same base, what can you do? You can set that exponents equal to each other. You can think of the bases as canceling each other out. You'll just get x equals 3. That's what we're doing with the logarithm. Because basically, exponents and logarithms are just like inverses of each other. So there's a lot of similar rules between them. Right, so let's do these last two examples. Example 4a. We want to solve this. It says solve for x. We have log base 8 of the quantity 3x plus 7 is equal to log base 8 of 7x plus 4. These are really simple. What do we got? We got a single log on the left side equal to a single log on the right-hand side. Both logarithms have the same base, so we can use that new property that we just learned here. We have two logs equal to each other, they have the same base, the logs and the bases will cancel each other out. So what we can do is we can just say 3x plus 7 is equal to 7x plus 4. And then what we have here is a really simple Algebra 1 problem. We just got to solve for x. So let's get our x's on the same side. Let's move the smaller one. So let's subtract 3x from both sides. And we get 7 is equal to 4x plus 4. Subtract 4 now on both sides. We get 3 is equal to 4x. And then last, we can divide both sides by 4. So we get x to be 3/4. Now the last thing you gotta do is just check and make sure you can use x equals 3/4. Because where is that x located? The x is located inside here. What's true about this number? Remember the definition of logarithm. That number has to be a positive number. It has to be a number greater than 0. So if you plug 3/4 in for x, do you get a positive number here? Yeah, we do. Do you get a positive number over here? I really don't care what the number is. All I care is that it's a positive number. So I'm not going to work it out. I'm just going to look at it and make sure it's a positive number. If I plug 3/4 then for x, does that equal a positive number? Yeah. So my solution is x equals 3/4. All right, let's look at B. Well, this is not an equation. This is an inequality. But you can use that same property. That same property works for inequalities as well. So basically, I can just, if you have this, if you have log base B of A is less than log base B of C, you can think of it as the logs as canceling each other out, and you just get A is less than C. Alright, so B, we got log base 5 of the quantity 2x minus 3 is greater than log base 5 of the quantity x plus 2. So these logarithms will cancel each other out, and we just get this. 2x minus 3 is greater than x plus 2. Now, let's just solve this for x. So let's subtract x from both sides. We subtract x from both sides, we get x minus 3 is greater than 2. Add 3 to both sides, we get x is greater than 5. So the solution is all values of x that are greater than 5. Let's make sure we can use those. Let's make sure all these values, when I plug them back in here for x, let's make sure they are going to make this expression here and this expression here a positive number. If you plug in any number greater than 5 here for the x, would that always be a positive number? Yes. What about, it will always be a positive number on that first one. Would it always be a positive number over here? Yes. So this is the solution. X is greater than 5. So for today, what I want you to do is I want you to finish that assignment that I handed out yesterday. So I want you to do 10 through 21. And make sure to show all your work if you want to receive full credit.